So recently at LinkedIn, we underwent a big task, and that we converted our main application, the one that we've talked about in multiple venues, to using engines. And so we wanted to give kind of a public talk on why we did that, how we did it, kind of how the setup looks like, and then some of the challenges we faced along the way. Since engines are a relatively new technology, there's a lot of excitement around them, but I think there's also kind of a misunderstanding about some of the benefits that they can bring, as well as some of the challenges that you'll face in adopting them. So without further ado, a bit of background about myself. On most social media, as well as GitHub, Twitter, etc., I'm known as Trent and Willis. You might have seen me around. I'm a software engineer here at LinkedIn, where I work on our infrastructure team for our flagship product. And so a lot of what I do is related to kind of building out frameworks, as well as supporting developers as they work on our products. I contribute to several various open source initiatives, and I really like music. So if you're into like heavy metal or hardcore, come talk to me. So this is our app. Hopefully you've seen it. If not, that's what it looks like. This was from before we started converting to engines. Pretty standard. About a month later, this happened. There was much excitement. This was our project lead kind of tweeting out about the fact that we have successfully deployed engines to production. So engines are totally viable. We have them running in production now. And this is what the app now looks like. Exactly the same. And so the first question that we usually get is why engines? We spent a month working on it, and it looks exactly the same as it used to. And so to a lot of people, this kind of seems like a waste of time. So we're going to talk about why we decided this was a good idea. I think the first stopping point for us is the engine's RFC. If you take a look at the motivation section, it pretty much describes the situation that we had at LinkedIn. It talks about applications that have multiple discrete sections, or as we call them internally, pillars. It talks about having a distributed team or groups of teams that work on this single application, but they're all responsible for different areas. It also talks about the pattern of kind of having a shared navigation that leads into different tabs. Each of those tabs could be kind of considered its own application in itself. And then it also talks about artificial namespaces. Kind of this idea that we enforce code conventions just by putting stuff into a folder rather than actually having clear separation inside our applications. So all these things down to a T described what we were doing at LinkedIn on this application. And so we figured, why not? It makes sense. More concrete benefits, though, other than the fact that it just made sense, is that isolation. This is a thing that you'll hear talked about a lot in regards to engines. I think the most oft-quoted benefit of isolation is that it enables lazy loading by allowing you to take a chunk of code and just saying, this can be separated, and then we can just add it in at this single designated point later on when we need it. But more importantly, and the reason why we did it now as opposed to later when we actually could have lazy loading, is that it makes it easier to reason about your application as a whole. Before doing this, our dependency graph internal to the application was kind of all over the place. You could be working on one area's code and have some random test fail in another area, and you'd have no idea why. And it would turn out because implicitly they were sharing some code. Maybe they had some component that they both used, but wasn't properly namespaced to be inside the shared directory or something to that effect. Now, after moving to engines, we can resolve a lot of that stuff more programmatically, and it's very clear because you have to be explicit about what you're importing and what you're relying on. It also helped reveal some bad architectural decisions that we had made. Things such as weird routing decisions. So like if you're trying to break out functionality that you think should be an engine that lives at a specific route, if it's not set up that way in your router map, then you're going to need to restructure your code. And so that's something that we had to do for certain areas, as well as it revealed areas where we were reusing code that we shouldn't necessarily have been reusing or sharing code. We'll talk a bit more about that stuff in a little bit. So the next big benefit was distribution. As mentioned before, we have a distributed team. Currently, there's something probably close to 9 or 10 sub-teams that work on this application. We're scattered. We have developers sometimes working from Sunnyvale or another state. We have developers up in San Francisco. We have a lot of developers here. But even in this specific campus, we have developers working from the various buildings on campus. And so giving them kind of clean separation in the code base makes it a lot easier for them to reason about where exactly they belong inside that code base. And it gives them the freedom to move at a more independent pace rather than being tied to the velocity of the overall larger project. It gives us true namespacing. So no longer is it just this happens to live in this folder, so therefore it has this namespace. It's now, okay, this belongs to this engine, so at build time, the modules actually have a defined namespace. And because of the way engines work, you can now only use things that are actually existing in that namespace within your code. And so as mentioned before, that leads to it being easier to reason about the code and enabling things such as lazy loading. Then finally, clear integration points. We know more or less exactly how everything fits together now. And whereas before it was kind of difficult to figure all that out, even though we had very clear tabs in our application, you weren't always 100% sure how the code that rendered on that page made it to that page. And that happens when you get to any sufficiently complicated application. Especially one that's just to span multiple teams and is traded off hands over the course of a year or more. And finally, we did it to prepare for the future. So lazy loading primarily, it's a huge ask that we would love to have in the near future. And this is obviously for performance. Performance is a huge thing when you're developing a mobile-first application. And there are huge benefits to have from breaking up your application. So, for example, our application, when fully built in development, can be upwards of 5 to 6 megabytes. And that's a huge file to ask your client to download all at once when they might only be using a small subset of those features. There are other things that could potentially come in the future as well. So kind of a, I guess, derivative or offshoot from lazy loading is this idea of tree shaking and figuring out which dependencies are actually being used, which code is actually being used, and shedding dead weight. Breaking stuff up into a more modular format, such as the add-ons that represent our engines now, allows us to later break them out into separate repos if we decide that we need to reuse them across multiple platforms. And modularizing our code allows us to compose them in more interesting fashions. So I'll talk more about that after the next section. So what's unique about our approach to engines? On the surface, it seems relatively straightforward. We took an app, we broke it up into a bunch of different sections. But in doing so, because of the unique constraints in the way that our app interacts with different parts of it, we had to consider some unique challenges and we arrived at solutions that we feel like are relatively unique. So the first one is we have a single repository still. Even though we have a bunch of engines in that repository, it all still lives underneath one repository. And so the first question a lot of people ask is, why didn't you break it out? Why don't you have all your teams have their own dedicated repository and then assemble them during your deployment? And there were several reasons why we opted to follow this approach. The first one is that even though the teams are distributed and the areas are relatively easy to see the boundaries from a user perspective, inside the code, it's relatively intertwined. We do still share code between different areas. And so if you were to break this out into a bunch of different repos, in order to get the app up and running locally and to make changes that potentially affect shared code or code that's used by more than one pillar, you'd wind up having to clone down 3, 4, maybe 5 different repositories and building them all to test your changes across all of them, which is not fun. Additionally, we wanted to maintain a single deployable. And the reason for this is that we haven't quite got to a point where we can have auto deployments, and we don't have quite the quality and testing coverage to achieve that at this point in time. Something that we're working towards, but we're not quite there yet. And so having to deploy multiple applications all manually in order to have a single application up and running for the user is, again, another cost that we didn't want to incur upfront. So the final reason, and probably the most important one though, was that we needed an easy way to ensure dependencies are synchronized. So when you're working with 8 to 9 or potentially more teams as the application grows, managing dependencies across all those teams becomes really difficult. And if they're all running in their own repos and their tests are passing with the set of dependencies that they specified, like that's great, but then what happens when all of a sudden they're merged into this consuming application and the dependency expectations of that application are different from the dependency expectations of the engine. And so that's a risk that we really wanted to mitigate, especially given the fact that we're working towards continuous deployments. And so obviously that incurs some additional costs with it. We have to encourage all teams to upgrade at the same time, as well as we have to make sure that we keep our dependencies relatively up to date, so that way no one team gets stuck using outdated patterns, and then when we do go to update, it becomes a lot more difficult. So the next thing is building on top of that, is we adopted a single source of truth for our dependencies for multiple applications. And so this is kind of a confusing concept, but essentially what happens is none of our engines or our application live in the root of our repository. Rather, they all live in subdirectories. And so in the root of our repository, we specify a global package.json and bower.json file. These files allow us to list out all the dependencies that are potentially needed from all the different engines or applications and install them at a global level. We then symlink these into the various engines, add-ons, and application as a way to make sure that they're all standardized and all pegged to the same exact version. Now, we could obviously enforce some standard that all teams must use the same exact version, but that becomes difficult and requires additional tooling. As an added detriment, it would also mean that anytime you go to install dependencies for the application, you wind up having to install things multiple times. And as many of you probably know, when working on reasonably large applications, running npm install more than once is frustrating. And then when you have to do it, say 12 times, it would be miserable, and you would be wasting large portions of your day. Again, the drawback here, though, is that everyone has to upgrade at the same time. But the cost of that is less to us than the risk of potentially diverging and having conflicting dependency versions when we deploy our application. Finally, we can now compose and extend engines and add-ons. And this is something that we're doing that I don't think has been talked about a lot in the engines space. And that is not necessarily that we add add-ons to our engines, but that we use our engines as add-ons as well. And I'll talk a bit more about this in the next section again. But by modularizing all of our code into add-ons first, we are able to kind of reassemble them into different and more unique ways. And this is really important for us moving forward, because as we want to expand our application, we might want to start extending the engine code that we already have there. So those are some of the, I guess, more unique aspects of the approach that we took to using engines. So let's talk about how we actually got there. So how do you migrate to engines? Warning, there are some very overly simplified visuals ahead. It's more just to communicate an idea of like how you can visualize this mentally, rather than stepping through it piece by piece, because there would be a lot of code involved in that. So our first step is you have to acknowledge the investment. It's not cheap. As I said, it took us about a month, and that was with a team of roughly a dozen developers locked into our room, and that was what they were working on for that month. And so we have to realize that it's going to be an investment in the long term, and it's not just a cost that we're paying because we wanted to do it. And so that investment goes back to all the whys that we covered before. The next step is establish a solid plan. And so this is very generic advice, but one thing that we found is that since engines are such a new technology, throughout the migration, we encountered issues that we weren't expecting. Whether that was some feature that wasn't supported by engines or some edge case that we hadn't considered with the way our app was architected. Having a solid plan helped us not lose track in momentum, even when we had to shift courses a little bit. And third step, lock yourself in a room. Actually, locking the door would be optional, but given the magnitude, it would be really easy for an initiative like this to turn into a never-ending upgrade cycle. If we had allowed teams to kind of do it when it was convenient for them, it would have been very easy for some teams to be like, oh, okay, we'll get to it after we finish product X. But then product X winds up having some additional features placed on top of it. And then before you know it, it gets pushed down this pile of priorities, and it never gets finished. And so as developers continue to develop on top of the app, it makes migrating to engines even more difficult. Additionally, getting yourself in a room with a cross-section of different team members from various teams that all work on this application that you might not work with on a regular basis can be kind of fun. You get to meet and interact with people that have different perspectives from the ones that you're used to working with, as well as you just meet more people in your company, which is always a good thing. Okay, so we'll get into the real stuff now. So probably the most practical tip I can give to anyone that is thinking about adopting engines is to turn everything into add-ons first that you're planning on turning into an engine. It's very tempting that once you start moving your code to add-ons to just go all the way and say, oh, well, we should just go ahead and make it an engine. And the reason why I would advise against this is that engines bring with them a lot of new concepts, one of which that can be particularly difficult to deal with is the idea of namespaces. And so a lot of Ember developers that we worked with had never really developed add-ons. And so the idea of there being different namespaces present within a single application was not really something that had occurred to them, and they didn't really understand how it worked. So by adopting an add-on pattern first and kind of going through the motions of figuring out what the add-ons namespace means as opposed to the application's namespace, how re-exporting something from the add-on namespace into the application namespace works, and all those various concepts can be very beneficial, especially when you start having to do weird stuff like refactoring your components to only reference links that are internal to the engine, and refactoring your templates so that they only use partials and components that are available within the namespace that you have for your engine. So what that looks like is that you might start out with an application that has all these weird sections in it, and they're all kind of intermingled. And then by the end of this, they should be moved out into add-ons, which gives them a bit more organization. There might still be some weird intermingling, which is why they don't really have any clear boundaries, but you should be able to reason and figure out a rough idea of where those boundaries are. So then the next step, obviously, is turn those things into engines. Introducing engines at this point obviously means introducing isolation, which means that you have to identify the edges of your engine. And by edges, this means things like dependencies. You have to figure out, okay, what components am I using that don't necessarily belong to my section? What things am I importing from a shared namespace? As well as figuring out, okay, what global services or global state was I previously relying on that is no longer present? And you have to kind of piecewise work through these things. At one point, a sentiment in our war room effort was that it feels kind of like just knocking down error after error. You fix one error, and then Ember rebuilds, and it serves again, and this time you have a new error. and you have to fix that error. And then you do this again until you finally get a page rendering. And then you go on and do it in the next page. And this can be frustrating at times, especially working on something as new as engines, which hadn't really had a lot of proving out in full-fledged production apps. So sometimes we ran into issues that were actually problems with engines itself and not problems with our app code. And so we had to go and fix those. Other times, though, it was really simple stuff where it's just like, oh, I just need to remove this pseudo namespace that we no longer need. So all that to say, it can be frustrating and things will probably break, but it's worth it. So at the end of this, should look like this. Now that you have engines, there are more clear boundaries. Your package JSON should specify the add-ons that you're dependent on and the code that you're importing. And your Engine.js file should specify the services and the external routes that you're dependent on. And the combination of these two things should give you a very clear picture of the code that you're using that is not contained within your engine. So what did we learn from all this? So now that we have an app built with engines, was it worth it? And then what are some of the key takeaways that we had from this? So first off, we definitely think it was worth it moving to engines. We've had great velocity on the next phase of the project that we're starting on. And we also had some benefits and learned some things that weren't immediately apparent from the idea of moving to engines. So this first one is the Engine-Addon dual nature. I mentioned this before. It brings with it good and bad things, possibly. But we've seen a lot of good come out of it. And so this comes from the fact that engines are largely a runtime characteristic, as is evident by the fact that it's an Ember.js RFC, not an Ember CLI RFC. They enforce isolation at runtime, and they are a runtime concept. You have to call engine.extend. And so on the flip side of that, you create them as add-ons, but add-ons are by and large a build time characteristic. They specify kind of how Ember CLI pulls things together. They provide build hooks. They allow you to build stuff into different module namespaces. And so you can leverage aspects of both of these. Specifically, we have certain engines that we use that both function as engines inside our application, but we also share some components from them as an add-on would. And this is really important to us because there are several features in our application, such as messaging, that while they have their own specific area in the application, we also want to deeply integrate into other areas. So if you're scrolling through our LinkedIn feed, you should be able to message someone that you see from that feed. You shouldn't have to go all the way to the separate experience just to invoke those components. And so this opens doors as you start thinking about it more and modularizing your code more to where you can potentially have subparts of these engines that are themselves more modular engines and then compose them into a more holistic engine. And you can share components through using them as add-ons. So all that might be a little bit confusing. So I would encourage you to play around with it at your own leisure, because there are some really cool and powerful things that you can do with that idea. So another thing that we learned in our key takeaway was that explicit boundaries both rock and they really suck. So as mentioned before, they can be really annoying when you're trying to knock down issues and errors, and they just seem to keep popping up, and it's all over stupid stuff like you didn't import a component from some shared add-on. That can really be super annoying, but you have to realize that this comes with the added benefit in the future of things such as lazy loading and the ability to reason about your app more. So they rock for all the reasons that we talked about why we wanted to move to engines, and they suck for things that they can be really tedious. As a side note on that topic, there is a lot of discussion about the idea of sharing components between engines And so this is obviously an area that not just we felt at LinkedIn, but other people that have tried using engines have felt themselves. And are engines an end-all be-all? Not quite. When we started out with the problem, we had this great idea that our application structure was going to just be like application and then like 5 engines, and that'd be it. And it'd be super simple, super great. Everything would be happy. Everyone would be happy. It's not quite true. Engines are great for a lot of our use cases that we've had here, but they don't really solve everything. There's still some issues that we're working through with regards to what happens when you have functionality that looks very similar, but differs just enough that you can't really make it into an engine. And we still have plenty of add-ons. Not everything that we started modularizing was turned into an engine. A lot of things are still add-ons that are just then consumed by the various engines. So I guess the way to summarize this is some product designs break down nicely into engines, but others don't. And so you should really be cognizant of that as you're evaluating whether or not engines are right for your project. Then finally, hard problems. They still exist, and you should help solve them. So there are the obvious hard problems, such as lazy loading and tree shaking and figuring out optimal ways of sharing components. But then there are some not so obvious hard problems, such as how do you share data from the host application with mounted engines when those engines potentially need models that the original application didn't have, but you still want that data. And there are also non-technical hard problems, such as how do you explain the difference between an engine and an add-on to someone that doesn't have a background in Ember, and all the education that goes along with that. So obviously there are some answers to these, and there are definitely ways of approaching them. But as a community, we need to work together to find the best solution and rally around those and support those ideas. And so, being that Ember is open source and Engines is open source, highly recommend getting involved, especially if this interests you at all. A lot of people always wonder what's a good way to get involved in open source, and something like Engines is a great opportunity. It's relatively new, and there's a lot of hype around it, and a lot of people want to be involved in it, but it's not very battle tested yet. And so by getting on the bandwagon early, you have the opportunity to find areas that need improvement and actively kind of contribute back to those. As a personal note, I was super thrilled when we had multiple new developers who haven't really contributed to open source have opportunities to contribute back because we were adopting engines. So yeah, so that about does it for me. Again, I'm from LinkedIn. We're hiring. Are there any questions? Yes.
Two questions. First, you lazy loading. Run up to the mic, please. Oh, sure. Line up there. We're recording, so our viewers at home. Hi there. 2 quick questions. First, is lazy loading possible today, and are you guys doing it?
So the short answer to that, and I guess the community-backed answer is no, it's not supported. The answer for us, though, is that yes, we have attempted lazy loading, not to the extent that we would like to see it done, or with the rigor that we think really needs to be in place for it to be a long-term solution. It's something that we're actively working on, and we've been very invested in the community trying to approach and solve those problems.
Cool. Second question is, do you have any metrics just based on maybe the size of the engines, how much percentage-wise you've been able to isolate from, say, like the first LinkedIn user experience that in the future won't have to be loaded right away?
Oh, so if we were able to lazy load. We don't have any hard numbers. I will say that with the current rendering engine and implementation of handlebars, by separating out templates, which we do currently lazy load, we cut our application size about in half. So there are definitely huge gains to be seen.
Thank you.
Any other questions?